Hi guys. So now, in this video, we'll discuss about the serverless and application services. All right. So we'll begin with Lambda function. Okay. So creating Lambda function and a CloudWatch Lambda function database. Yeah. Okay. Okay, what is Lambda? You know. Uh, so we create a AWS Lambda function. We deploy a code. Code to it. Test the function and view its CloudWatch logs. That's a use case. Okay, but like before that, what's the Lambda function? Okay, you can use AWS Lambda function to run code without provisioning or managing servers. All right, so you don't want any servers. Without that, you can run the code. That is nothing but Lambda function. Okay, okay. In simple terms, code on a high availability code. This runs your code on high availability compute infrastructure and perform all the of the administration of the compute resource, including server, operating system, maintenance capacity, provisioning, and automatic scaling and logging. With Lambda, all you need to do is supply your code in one of the language runtimes that Lambda supports. That's it. All right. So to create, we'll see this example. To create an AWS Lambda function, deploy code to it, test the function, and view its CloudWatch logs. What we do? We create a Lambda service. Okay. You deploy the code to Lambda function, test the Lambda function, and view the CloudWatch logs. Right? Whatever the logs you will get, you can watch it from the CloudWatch. All right. So to create a okay, we'll see next example. To create a configure a Lambda function along with the Lambda layer for enhancing functionality and managing dependencies. All right. First, what we're gonna do? We configure a Lambda function along with a Lambda layer for enhancing functionality and managing dependencies. We create a Lambda function. What we do? We set up a new Lambda function with Node.js. Create a Lambda function. You set up a new Lambda function with Node.js, and AWS handle the permissions automatically. You know, so we had a Lambda layer, which means you attach a pre-built AWS layer. Lambda Insight extension version 5.3 to your function. This layer brings extra functionality like monitoring and manages shared code or dependencies. Okay, we will see what is this pre-built Lambda layer. Yeah, yeah. See, here you have Lambda layer for the package libraries, and other dependencies to reduce the size of deployment archives and makes it faster to deploy your code. Add a Lambda layer. So you attach a pre-built AWS layer, Lambda Insight extension version to your function. This layer brings extra functionality like monitoring and manages shared code or dependency. All right. Okay. So some we will see some key features. Okay. Environmental variable. So we use environmental variable to adjust your functions behavior without updating code, right? Versions. So we manage the deployment of your version with versions and container image. Create a container image for Lambda function by using a AWS provided base image or an base image so that you can reuse your existing container tooling or deploy large work. All right, Lambda layers, as I told you, package libraries and other dependencies to reduce the size of deployment archives and makes it faster to deploy your code. Lambda layers, okay? Lambda extension function URLs are a dedicated HTTPS endpoint to your Lambda function. You know, okay, the response shaping, concurrency and scaling control, code signals, private network file system, Lambda snapshot. Lambda snapshot to provide a low sub-second startup performance. So these are all the things you can check. Okay. Thing you have to keep in mind is okay, Lambda layer. Okay. You attach a pre-built AWS layer that is Lambda Insights extension version 5.3 to your function. This layer brings extra functionality. For example, like monitoring and manages shared code or dependencies, right? Okay. Next, we will see one example that is creating a serverless web application. I'll repeat, creating a serverless web application. Okay. And creating a serverless web application. So to create a serverless web application on the Amazon Web Service platform. Okay, we'll see. Okay, steps we will see. Cloud Shell. So your built-in command line where you um, commands, it's a built-in command line interface where you provide commands, these are something you have to keep in mind. Cloud Shell, right? Your built-in command line interface where you command, okay? And if there is some command I will tell, like SAM init, okay? This starts a new serverless application project, okay? In the command line and template and settings. So you choose a simple allow template in Python something. Okay, these are the settings I'm telling steps. Okay, Python 3, which extra settings like X-ray enable something. Build and deploy. You compile your application and deploy it to AWS. Okay, and you test. Finally, you access the provide URL in your browser to see your serverless hub is working. Basically, what we do is we are compiling and deploying a simple web application, deploying it, whatever the URL we provided in the from the AWS, we check in the browser whether to see your serverless web application is in action. Right? That's the example. Okay. Okay. Now, okay, I understood about the Lambda, how to create a web page, app, and deploy and test all right. Yeah. Libraries are okay. Now we will understand about the creating SQSQ, visibility timeout and DLQ. Okay. Okay. The example here is to create and manage an Amazon SQS standard queue, emphasizing the concepts of visibility timeout and dead letter queue. Okay. Okay. What is this SQS? SQS. Yeah. Let's see what is this SQS. Uh, Simple queue service. Yeah. So it's a service that helps different parts of an application communicate by sending messages. Okay. Think of it as digital mailbox. Okay. Where messages are stored until someone is ready to pick them up. Okay. Think it as a digital mailbox where messages data are stored until someone is ready to pick them up and process them. Okay. I repeat, simple service queue is a service that helps different part of an application communicate by sending messages. Think of it as digital mailbox where messages are stored until someone is ready to pick them up and process them. All right? Yeah. Message, right? Okay. I was telling about, okay, someone understood about the skiers. Now, just wanna mention about message criterion, which means we are sending to the queue. Means when something happens, like a customer placing an order, the details of that order are packaged as message and placed into the SQS queue. This is like we are dropping a letter into a mailbox. Okay, we have a mailbox. We are dropping a letter into a mailbox. This is message criterion. Okay, I repeat, when something happens, like customer placing an order, you know, the details of that order are packaged as message and placed into the SQS queue. This is like dropping a letter into a mailbox. That package is something you consider as message, a letter, and we are dropping it to a mailbox. Okay. Message processing, retrieving from the queue. Okay. In the queue, we have a data. We process that message. It's something like a separate process of service. For example, a server or a Lambda function periodically checks the SQS queue. You know, when finds a message, it picks up the message to process it. Okay. Like this server or the lambda function, these will periodically check, okay, whether the SQS has any message. If as soon as it get message, it takes it and it processes it. Okay, visibility timeout. I was telling, once the message is picked up for processing, you know, it's hidden from the queue for a set period. This is like lock on the message, you know. This ensure that no two process try to handle it. The same message at the same time. If processing completes successfully, the message is deleted from the queue. Okay. Which means once the message is picked from the processing for processed picked up for processing, it's hidden from the queue. Okay, it's hidden from the queue for a set period. This is like lock on the message. This ensures that no two processes try to handle the same message at the same time. Two process, which means that okay, once the message is picked up, it is hidden from the queue because it shouldn't be like picked from the other processes, right? So the reason this ensure that no two processes try to handle the same message at the same time. If processing completes successfully, the message is deleted from the queue itself, right? Yeah. And I was telling about delete letter queue. This is delete letter queue means here, if a message can't be processed after several attempts, for example, if there are error in order processing, uh, it's moved to a special queue called a dead letter queue. This lets you isolate problematic messages for further analysis or reprocessing. Okay, if a message can't be processed after several attempts, then this message move to delete letter queue. So later we can use this for further analysis or reprocessing it. All right. So this is all about SQS standard queue, visibility timeout, and dead letter queue. But to keep in mind that to create and manage an Amazon SQS standard queue, simple uh, SQS standard queue, visibility timeout, and dead letter queue. Okay. Visibility timeout, as I told, once a message is picked, process, it's hidden from the queue for a set period so that no two processes will process the same message. Dead letter queue, uh, uh, once the message is if not processed properly, so that message will go to delete letter queue for later analysis and reprocessing it. All right. This is about SQS, standard queue, visibility timeout, and DLQ. Right? Yeah. So now next we'll see about creating SQS queue, duplication ID, and message group. All right. SQS queue. So creating SQS queue, duplication ID, and message group. What it is? Okay. To provide a practical understanding of creating and utilizing a first in first out queue in the Amazon simple queue service. Okay. So we wanna do perform before first in first out queue in Amazon simple queue service. Okay, how we can do this? First steps are we create a queue, send a message with group ID and duplicate ID. I repeat, group ID, we send a message with group ID and duplicate ID. Okay. What is this FIFO queue? I told you, first in, first out. Okay, think of it as a line where the first person to join gets served first. In SQS also, okay, it's something like if you go to any counter, you know, or till or somewhere to buy something, you will form a queue. So people who go first, they will get served first. Yeah. Similarly, in SQS, messages are processed in order they are sent. Okay, messages are processed in order they are sent. Okay, okay. Message group ID. What is this message group ID first? Suppose you have a family. For example, I'm telling coming together in that line. That line. I'm telling line in a sense the consider it as FIFO. You know, all member of the same family messages with the same group. Okay, group stay together in the line. Okay, this keeps their order in the correct order. Message group ID means suppose you have a family. For example, I'm telling in real world, yeah, coming together in that line. All member of the same family messages with the same group ID, messages with the same group ID, stay together in the line. This keeps their order in the correct order. They come together as a group. The message comes as a group, all right, with the group ID. Okay. What is this duplication? Sometimes someone might accidentally join the line, twice with the exact same order. Duplication makes sure that even if that happens, only one order is taken, so you don't serve the same order twice. So duplication will, okay, you have given a group ID, right? So it will check, okay, if this group ID has come again. If this duplication ID will check that, okay, if it is came earlier or future, it will not serve again. It's like a duplicate. Sometimes someone might accidentally join the line, yeah, twice with the exact same order. So duplication makes sure that even if that happens only once, order is taken, so you don't serve the same order twice. Okay. So keep in mind SQS queue, duplication ID, message group. You have to keep that group ID is something like group ID given to group of messages, and duplication ID is that will check whether the same ID shouldn't make sure that that doesn't come twice. Okay, that is duplication ID given. All right. Okay. For an example, right? Okay. I'm gonna give one example for this SQS queue, duplication ID, and message queue. You know, um, what we do, okay, we create a FIFO queue. What you do, you open the SQS console, the AWS, and create a new queue. Choose the FIFO queue type, which ensures measures. mm, You have to mention that it's a FIFO queue type, okay, which ensures messages are processed in order, and name it like something like FIFO or something, yeah, dot FIFO. Note the dot FIFO suffix is required here, okay, and you enable content based duplication so that if you send the exact same message content within a short period, it isn't duplicated, okay. Okay, then you click finalize, create bucket, and you create the plugin to finalize the queue. Okay, then to test it, like, okay, send a message with group ID and duplication, right? In the queue console, go to send and receive messages. There, you enter in the message title, for example, message body. You give hello first message and message group ID. Example, like, okay, you give group ID. This groups similar messages together for ordered processing. Okay, this groups similar messages together for ordered processing. Similar messages. Okay, and you form it as a group ID and use it. Okay, so you send the message and then check and view the message. Use the poll for messages to retrieve and view the messages you sent. Okay. The FIFO queue ensures that if you send a duplicate message with the same content and the same group ID, with the same content and same group ID, within the duplication window, it may ignore the duplicate. Okay. If you modify the message body and resend using the same group ID, the queue will treat it as a new message, okay, resulting in multiple message being visible. This is the idea. So if it's the same content, if the same group ID, it will ignore. If it is like you change any message and if you send, then it will duplicate. So if you modify the message body and resend, it will duplicate and yeah. So this process, which demonstrate our FIFO queue manages message order, which eliminates duplicate messages using content-based duplication and group related message together with a message group ID. If you are sending a similar messages, you form you have option group ID. Okay. Yeah. Okay. Um. Next, next we will see about creating a Kinesis data stream. Okay. Okay. Now, we will discuss about the creating a kinesis data stream. All right. What is this kinesis? We'll see what is this kinesis. All right. Okay. To create a kinesis data stream in Amazon Kinesis, to set up a data stream, configure its capacity and understand the concept of shards as a fundamental resource in kinesis. Okay. We will see what is this kinesis first. Okay. What is this kinesis? We will see. Okay. So to create a okay, what is this kinesis data stream? First, we will see what is this data stream. Okay. Think of a Amazon Kinesis data stream like a something like a river, for example, that carries water. Data. Water means you consider a data. In this case, the data is continuously flowing through the stream. Okay. Data stream, Amazon Kinesis data stream is like a river that carries water. All right. So in this case, the data is continuously flowing through the stream. Okay. What is shards? The river can have several channels, right? Or lanes. In kinesis, these lanes are called shards. Okay. You keep in mind, river means kinesis data, okay, in which the water is flowing continuously. The data you consider as in kinesis data, the data is flowing continuously there in the river. If you imagine shards as different channels, same like in the shards, these lanes are called shards where each shards has a specific capacity. More shards means you can handle more data at once. You know, more shards means you can handle more data at once. Okay. Now you got data stream and shards here. Okay. Now we'll see like steps. You go to Amazon Kinesis, you create data stream. Okay. Data stream will be created. Then you do configuration in that where you edit the capacity mode. No, you edit the capacity, you select provisioned mode and you edit provision shard and use shard estimator. Okay. And you put total capacity, number of shards into capacity per shard. Number of shards, which means number of channels and capacity, the number of channels and then each channel, how much data it can hold. Yeah, that you can do. Capacity mode means when you choose provision, you're deciding in advance how many lanes, shards your river should have, your data stream should have, how many shards. And the shard estimator then tells you the total capacity. This shard estimator tells you the total capacity of the stream based on the number of shards you have. All right. So this is the term. capacity mode variable type. Okay. So this is about the Kinesis data stream. Okay. So you have to keep in mind data stream, shards, and the capacity mode. All right. Okay. Next, we'll see creating a Kinesis data firehouse. Okay. What is firehouse? We will see. Yes. Yeah. Okay. Here you can see. As I told, Amazon Kinesis is a fully managed AWS service for a real-time data streaming. A real-time data streaming, not a specific data warehouse. Okay, where you store the data and like analyze. No, it's not like that. It's for a real-time data streaming. Okay, it's a platform that helps business ingest, process, and analyze streaming data, while Kinesis data streams and Kinesis data firehouse can be used to load data into data warehouse like Amazon Redshift. In the Amazon Redshift, we do this, warehouses. Redshift is for warehouse data and analyzing. Yeah. Kinesis itself is not a data warehouse, but rather a tool for building data pipeline, that can feed data into various data, can feed data into various data warehouses. All right. Yeah. Okay. Let's see. Firehouse. Yeah. To create a Kinesis data firehouse, set up an Amazon S3 bucket as a destination and test the data delivery stream. What we have to do steps, create a Kinesis data firehouse, create an S3 bucket. Okay. Firehouse. It's the tool that takes data from a source and streams it to a destination. Okay. As I told you, is a tool for building data pipeline that can feed data into various data warehouses. Yeah. Similarly, it's a tool that takes data from a source and streams it to a destination. Okay, wait. Let me check for a better explanation, or here only we will see key concepts. You see, a service that captures, transforms, and loads data streams into AWS data stores such as Amazon S3 and Redshift. Okay, a scalable and durable real-time data streaming service for collecting and storing data stream. That is Kinesis data stream. Kinesis data warehouse is a service that capture, transform, and loads data streams into AWS data stores such as Amazon S3 and Redshift. Yeah. Okay. With a very better understanding, we will see what is this Kinesis data warehouse. Okay. Think of fire as ever data delivery pipeline. Okay, it takes streaming data and automatically loads it into a destination without requiring you to manage any servers or streaming clusters. All right, automatically load it into a destination. The main is it will take data from a source and streams it to a destination. Your destination can be S3 bucket. Okay, now main feature fully managed, no need to manage infrastructure, near real-time delivery, data transformation, encryption, buffering option. Yeah. Common destination we can see Amazon S3, raw stream data. Redshift also running analytics and BI queries. You'll store this so that they can analyze. Yeah. Open search, HTTP endpoints, Splunk. Yeah, Splunk is one of the real-time monitoring and alerting. So we can also stream the data into Splunk as well. All right. Yeah. If you delivery stream is writing, for example, okay, these all use case example we see. Okay, easy to have pushes logs to Firehouse using AWS SDK. Firehouse buffers and optionally transform them. Firehouse writes the logs into a S3 bucket. If you want to collect any logs, Firehouse will write the logs into a S3 bucket. Pushes the logs to Firehouse using AWS SDK. Easy to app we have, right? That pushes the logs to Firehouse using AWS SDK. Okay. You are collecting app logs from an app running on EC2 and wants to store them in Amazon S3 for analysis. All right. Yeah. So this is about Firehouse. Yeah. Okay. I just wanna see one use case on my all video. I used to do at the end of the video one use case. Uh, yeah. For the serverless application services. Okay. We okay. The use case is initiating a Lambda function to copy content in S3 bucket. Okay. We initiating a Lambda function to copy content in S3 bucket. Okay. What's the project? Okay, we'll see. Description is to launch the Lambda function and perform the trigger operation on Lambda for processing incoming S3 events. Okay, which means, okay, as a solution architect, okay, you must replicate the contents of a bucket. As a solution architect, you must replicate the contents. You must replicate the contents of a bucket to other buckets deployed in different regions, thereby making the resource available. Okay, how we can do this? The steps would be, okay, you create an S3 bucket, you create a Lambda function, okay, and you create a Lambda function, you where you write the code as copy the content from this bucket to from one region, and you copy the content from that bucket to the another bucket region. Yeah, and you create a trigger, okay, and add a destination. Okay, which means, okay, you create a S3 bucket where for testing you put event occurs. Event occurs means, okay, whenever the event occurs, the content has to copy to another region bucket as well. Whenever in the S3 bucket, you the event occurs. Event occurs means you upload a file. Okay. S3 event is triggered. What happens? It goes to Lambda function. Okay. It processes the S3 event and it copies the content and it goes to SNS destination. You can ask me, what is this SNS? SNS replicates SNS. What is okay in this project? What is this SNS? Simple notification service. Okay, I wanna discuss something about SNS now. Yeah, yeah, SNS. SNS. Okay. Amazon Simple Notification Service is something is a web service that coordinates and manages the delivery or sending a message to subscribing endpoints or clients. Okay, something like okay in our use case. Okay, in this project, SMS notification service is used as a destination to send notification when a Lambda function completes its copy operation. This means that once the Lambda function processes an S3 event, like a new file uploaded, you know, and copies content between the buckets from one region to another region, it can notify the subscribers via email, SMS, or other AWS services about the event which has happened. This helps with real-time monitoring or triggering okay, this helps with real-time monitoring or triggering additional actions in your workflow. This helps in real-time monitoring. Got it? So this is about the this project, the hand which I want to share. And yeah, I think this is pretty much about the serverless and application services. Maybe in the next video, we will discuss about monitoring and automation services, right?